JAM 2018 Chemistry Solutions. Question number 1. On hydrolysis, aluminum carbide produces. In the given 4 options, aluminum carbide when reacts with water, it gives methane. So, option 1 is correct answer. Question number 2. Carbonic anhydrous is an example of. Given 4 options. In the given 4 options, option 1 is correct. That means carbonic anhydrous is used to hydrolyze the carbon dioxide. That means this is an hydrolysis enzyme. So, when we use this enzyme, carbon dioxide reacts with water and give carbonic acid. So, that is the reason why we call it as hydrolysis enzyme. Question number 3. The correct order of melting points of group 15 trifluorides is. In the given 4 options, option 1 is correct. Melting point is always directly proportional to the molecular weight, and the given one option, option 1, that is the increasing order of the molecular weights. So, we can say increasing order of the melting points also. So, in the given 4 options, option 1 is the correct. Question number 4. Sodium fluoride, potassium fluoride, magnesium oxide and calcium oxide are crystalline solids. They have NaCl structure, that means FCC. Their lattice energies vary in the order. So, in the given 4 options, option 2 is the correct. Now, let us see how it happens. Here the lattice energy is inversely proportional to the sum of the ionic radius of cation as well as anion. So, this is the increasing order of the R plus and R minus. So, this will be the increasing order of the lattice energy. So, in the given 4 options, option 2 is correct, that is B option is correct. Question number 5. The major product formed in the following reaction is. Here this is the given compound. When it is reacting with NH2 minus, that means NaNH2 minus, that is given in the question. This reagent, that means this base can take the proton which is more acidic. Here this hydrogen is more acidic. So, this base can take the hydrogen from here, as a result we will get carbon ion, and this carbon ion can attack here, as a result nucleophilic substitution reaction takes place. So, in the final product we are getting this one. In the given 4 options, option C is the correct answer. Question number 6. The compound that contains the most acidic hydrogen is. In the given 4 options, option B is correct, because when the hydrogen is attached to the sp carbon, it has more acidic in nature because of high S character. In the sp, sp2, sp3, sp has more S character, so it also has the more electronegative character. That is the reason why hydrogens which are attached to the sp carbon has the more acidic in nature. So, option B is the correct answer. Question number 7. The C2 epimer of D-glucose is. In the given 4 options, the option A is correct, that is D-mannose. Now, let us see how it. Here these are the 2 structures of the D-glucose and D-mannose. We can observe that at C2 carbon, these 2 have the difference in the geometry or difference in the structure. So, we can say that these 2 are the C2 epimers. So, in the given 4 options, option A, that is mannose, is the correct answer. Question number 9. The number of crystal systems and the number of Bravais lattices are respectively. So, generally we have 7 types of crystal systems which are classified into 14 Bravais lattices. So, in the given 4 options, option D is correct, because we have the 7 crystals and 14 Bravais lattices. Question number 10. For adsorption of a gas on a solid surface, the plot that represents Freundlich isotherm is. Given things are in bracket x is equal mass of gas and m is equal mass of adsorbent and p is equal pressure. So, we have given 4 options, let us see which one is correct. According to Freundlich, x by m is equal to k into p to the power of 1 by n. Here n is nothing but which has the values between 0 and 1. When we apply log to this expression, log x by m is equal to log k plus 1 by n into log p. So if we take log x by m versus log p, we will get the slope 1 by n and we will get the intercept is equal to log k. So this resemble with option 4 in the given 4 options. So option 4 is the correct answer. Question number 11. With respect to periodic properties, the correct statement is, in the given 4 options, the option 4 is correct and the first 3 options, that is A, B, C are incorrect and D is correct answer, because ionic radius order is K plus less than, Ca2 plus less than, magnesium plus 2. But the remaining these 3 like A, B, C are the incorrect statements, because in the A, electron affinity order is given F greater than O greater than Cl, but the correct answer is Cl greater than fluorine greater than oxygen. In the option B, first ionization energy order is aluminum greater than magnesium greater than potassium, but the correct answer is magnesium greater than aluminum greater than potassium. And for option C, atomic radius order is nitrogen greater than phosphorus greater than arsenic, and the correct one is arsenic greater than phosphorus greater than nitrogen. So all these 3 are wrong options and the option D is the correct answer. And here we can also say size is inversely proportional to the atomic number. So when the atomic number increases, size decreases, or when the size increases, atomic number decreases, which has inverse relation. So option D is the correct answer. Question number 13. Among the following metal carbonyl species, the one with the highest metal carbon back bonding is? In the given 4 options, option 1 is the correct answer, because when the metal has more electron density around it, it can donate its electron density to the carbon of carbonyl group. So as a result, highest metal carbon bonding takes place, which is nothing but back bonding. So what I want to say is that metal carbon back bonding takes place with the highest intensity only when metal has more electron density. Metal will have more electron density when it has the more negative charge. In the given 4 option, option 1 has the more electron density because it has the 2 minus. That is the reason why it can donate electron density to the carbon. As a result, metal carbon back bonding takes place. So in the given 4 option, option 1 is the correct answer. Question number 14. The correct order of del O, that means the crystal field splitting of the d orbitals, values for the following anionic metal complex is? Here if we see the option B, in this the first thing is these two have the same kind of ligands. So here we have the cyanide, which is nothing but strong field ligand. As a result, we will have the delta naught values are more. So as we know that delta naught values are more or delta O values are more for strong field ligands. That is the reason why we have more del O values for these two compounds. In these two, why do we have more del 0 or del O values for this one? Because when we come from the top to bottom, 3D, 4D, 5D, in this case the delta O values increases from top to bottom. So here we have the iridium, that is the reason why its value is more when compared to rhodium. Okay, now let us see this one. This have the weak field ligand. So as a result, these values of the del O values are lesser than these two. Okay, because these are weak field ligands. As we know that when we have the weak field ligands, del O values will be less. So that is the reason why these two have the less when compared to the other these two compounds which have the strong field ligands. Now in these two, why this has the more crystal field stabilization energy? Because this has the 5D orbitals. So as we discussed earlier, top to bottom, the del naught values increases with increasing from top to bottom or with increasing that period. So here it belongs to the fifth, so it will have the more value followed by the lesser, and these values for this delta O naught values are very less because it is belongs to the 3D series. Okay, so two things are there. One is strong field and weak field. I is the weak field and Cn minus is strong field. That is the reason why this will have the more values, this will have the less value. When we compare the same group elements or same group ions, top to bottom delta naught value increases. So the B is the correct answer. Question number 15. The decay modes of carbon 14 and oxygen 14 are. In the given 4 option, option C is correct. Let's see how. Here C14 is converting into C12. As a result, we are getting beta decay. And here O14 is converting into O6. And here we are getting positron emission. And why we are getting these two things? Let's see here N by P value. That means N means number of neutrons and P for number of protons. When we take number of neutrons by the number of protons for this change, here we are getting 8 by 6 and 6 by 6. That means N by P value is decreasing. When we have the N by P values decreases, then we will get the beta decay. If N by P value increases, we will get the positron emission. Let's see how N by P value is increasing here. Here N value is 6 by 8 for this one and 8 by 8 for this one. So here N by P value is increasing. That is the reason why we are getting positron emission. So these are the two reasons for the beta decay and positron emission. In the given 4 option, option C is the correct. Question number 16. Consider the following 4 xenon compounds: xenon F2, xenon F4, xenon F6 and xenon O3. The pair of xenon compounds expected to have non-zero dipole moment is. In the given 4 option, option 4 is correct because xenon F6 and xenon O3 have the non-zero dipole moment. So let's see how. And here xenon F6 has distorted octahedral structure. That means it do not have any symmetrical structure. The compounds which do not have any symmetrical structure, those will have the dipole moment. That is the reason why it will have the dipole moment and it's not equal to 0. And here xenon O3, it also do not have any symmetrical structure, so it has the pyramidal structure. That is the reason why its dipole moment also not equal to 0. The thing is here symmetrical structures will have the dipole moment 0 and unsymmetrical structures will have the dipole moment not equal to 0. So in the given 4 option, option 4 is the correct answer. Question number 17. The correct order of stability of the following carbocations is. In the given 4 options, option C is correct. Let's see. So this compound is called as tertiary benzylic carbocation and this carbocation is called as bridged head carbocation and this is tertiary carbocation and this is primary allylic carbocation. Always there is less stability for this compound because whenever the carbocation is forming here, it should get planar structure, but here we have the bridged head carbons. That means bridged head carbon this is. So it is very difficult to form planar structure here. That is the reason why its stability is very less. So that's why I have written here. And this remaining 3 things, tertiary benzylic carbocation has more stability because here we have the pi bonds which will be resonance with this carbocation. As a result, it will get more stability. That is the reason why I have written here. That means it is getting first position in the stability order. The next thing is in the 3rd and the 4th option, always tertiary carbon has the more stable than the primary allylic carbocation. So that is the reason why tertiary carbocation has the more priority, then less priority goes to the primary allylic carbocation. So that is the reason why option C is the correct answer. Question number 18. Among the dimethyl cyclohexanes, which one can be obtained in enantiomer form? In the given 4 option, option 1 is correct answer because option B, option C and option D, these 3 compounds have the plane of symmetry. As a result, we cannot get pure enantiomer. But in case of option A, it doesn't have any plane of symmetry, so we can get pure enantiomer form. So option A is the correct answer. Question number 19. The major product formed in the following reaction is. In the given 4 options, option C is the correct answer. Let's see. Here pyrrole when reacts with CHCl3 in presence of sodium ethoxide, it will give CCl2 which is electrophile. So this will be attacked here. As a result, we will get this compound. and this is the unstable compound. As a result, it will go outside and this bond will shift to here, then we will get this compound. And here this compound has the positive charge here and this hydrogen nitrogen bond will shift to here, then we will get the double bond here. So this is the compound that we are getting in this reaction. So that is the reason why the option C is the correct answer. Question number 20. The product X in the following reaction sequence is. In the given 4 options, option 4 is the correct, that means option D is correct. Let us see. Here this is cyclopentanone. When it reacts with the titanium trichloride in presence of zinc copper, it will give just a simply addition product takes place. Okay, this compound in presence of cold alkaline KMnO4, it gives diols. So this is the diol. And when we add some acid to this one, any one OH will be attacked by the hydrogen. As a result, we will get the OH2 plus, and this bond will shift outside. As a result, we will get the positive charge here, and this positive charge will be accommodated to here. So as a result, we will get the double bond here at this carbon, and cyclic ring will be formed at the second carbon. So in the given 4 option, option D is the correct answer.